Hello, everyone. My name is Rick Balick, National Sales Manager of the Watson-Marlow Fluid Technology Group. I have been in the positive displacement pump business for over 33 years, the last 21 of which have been with the Watson-Marlow Fluid Technology Group. Today, we're going to be talking about peristaltic and sinusoidal pumps found in the paper industry. Some of the applications are found in, some of the benefits that they bring. First, peristaltic tubing pumps, as you see on your left, lower flow pumps up to 7 gallons per minute, up to 100 psi. You will find these in the chemical metering side of the applications. Virtually anywhere you can use a diaphragm metering pump, you can use a peristaltic tubing pump. Over on the right, you'll see heavier duty hose pumps. They use reinforced hoses with flows up to 400 gallons per minute at 232 psi. You will find these in maybe the back end wastewater treatment plant in a paper mill, pumping paper mill sludge. Also, sinusoidal pumps. Sinusoidal pumps offer the lowest shear of any rotary positive displacement pump available, flows to 600 gallons per minute, pressures at 217 psi, a myriad of flange fittings available, quick disconnects as you see here, again offering the lowest shear of any positive displacement pump rotary style available. You'll find these in the coating area. Quickly, some of the benefits that peristaltic technology brings to the table. Well, the largest benefit is one part, either the tube or the hose, which is very inexpensive compared to other technologies of positive displacement pumps such as rotary lobe or, say, progressing cavity. Every peristaltic pump is an inherent metering pump with accuracies up to 1/10 of 1%. Whether you need it or not, you're going to get amazing accuracy out of peristaltic technology. Peristaltic pumps can run dry indefinitely without damage, a huge benefit compared to other types of pumps. And if you need a suction lifting type of device, nothing better than a peristaltic pump is they can suction lift to 30 feet of water column. All peristaltic pumps are inherently reversible. They are as efficient in the reverse direction as in the forward direction. The pumps require no seals, no mechanical seals, no lip seals, no packing that come in contact with the fluid to leak or wear out. There are no inherent check valves with peristaltic pumps, unlike diaphragm metering pumps, to clog or wear out. Peristaltic pumps are ideal for viscous and abrasive fluids. In fact, the more abrasive a fluid is, the better a peristaltic pump looks compared to other types of positive displacement pump technologies, such as progressing cavity or rotary lobe pumps. And also, pump rebuilds take typically minutes or just seconds, not hours or days. Some of the ancillary pieces of equipment that simply go away or are not needed with peristaltic technology because the pump can run dry. There are no run dry sensors, switches, gauges that are involved. That's about a $3,000 expense on a typical size pump that's not needed. Every peristaltic pump, when turned off, is also an inherent check valve, at least 1 point, sometimes 2 or more, on the hose. The hose is completely squeezed shut. Not even air can escape it. A discharge check valve is something that is not needed, so that goes away. Because the pumps do not require any seal device that comes in contact with the fluid being pumped, no sealing water flush system is required. Peristaltic pumps, because they can achieve accuracies up to 1/10 of 1%, often eliminate the requirement of flow meters, as the pump is more accurate than the flow meter itself, be it a mag style flow meter, mass style flow meter, whatever, or flow meter, whatever it is. Peristaltic technology with accuracies to 1/10 of 1% are oftentimes more accurate than any flow meter. Diaphragm metering pumps, for example, require an ancillary device called an artificial back pressure valve. This is to sustain a minimum back pressure so that the diaphragm pump may be repeatable from the top to bottom flow rate. This device is not needed with a peristaltic pump. That goes away. And lastly, inline strainers, strainers to strain particulate away from other pump technologies. A peristaltic pump can easily handle the particulate, so a strainer goes away. All those aforementioned items, the cost of which they need to be added to the price of a new pump. They do not need to be added to the price of a new peristaltic pump. Some of the applications you will find: tubing pumps and disinfecting influent water. You will also find tubing pumps in optical brightener and dye applications. You'll find sinusoidal pumps in various paper coatings, and you'll find both tubing and hose pumps in the back end wastewater treatment plant in a paper mill. This is a good photo of a diaphragm metering pump skid with all of those aforementioned ancillary pieces of equipment. You'll see the 3 diaphragm metering pumps here, pulsation dampeners, a lot of the back pressure valves, degassing valves. You'll even see 3 flow meters, one each for each of these pumps. This entire chemical metering skid that you see on the right was replaced by these 3 peristaltic pumps. If you want to call it a skid, that it is. The pumps are very simple in design, as also are peristaltic metering pump skids. Again, everything you see on the right was replaced by peristaltic pumps on the left. A typical tote installation found in a paper mill, you'll see a typical chemical tote here, peristaltic pumps on the left. Some before and after photos, diaphragm metering pumps on the left, pumping anti-scale and biocide. They were replaced with peristaltic pumps on the right. Anti-scale, biocide, and dispersing agent pumps on the left. These are diaphragm pumps, replaced by peristaltic pumps on the right. Now, talking about the coatings in paper mills, titanium dioxide, kaolin clay, starch, liquors, cook starch, and sinusoidal pumps. The sinusoidal pumps will offer very gentle flow to spray coaters or curtain coaters, and you want reliability. And with sinusoidal technology, you will find virtually zero pulsation with the lowest shear available in the coating applications that we just mentioned. With the lowest pulsation, this improves product quality and equals less waste. Lastly, or next to last, dye pumps. You will see dye pumps. Oftentimes, you'll find old-style piston and diaphragm metering pumps. They are oftentimes difficult to control via poor accuracy. They're messy to maintain. However, peristaltic tubing pumps, as you'll see on the photo over right, with an element. This tubing pump uses a single tube right here called an element with the suction and discharge connection swaged on. There are valves on the inside for protection. This is the new standard when it comes to metering dye, pumping dye in paper mills. You will see a skid here of a number of peristaltic tubing pumps on dye addition. You will find this type of system all over the world when it comes to the dye application. Peristaltic pumps are the new standard when it comes to dye. In fact, many system integration companies have now standardized on peristaltic tubing pumps in their dye system, integrated systems, as you see here. So tubing pumps have often replaced and is now the standard for dye applications, replacing piston pump and diaphragm metering pumps. Lastly, wastewater treatment. Every paper mill uses large amounts of water in their process. They must treat this water before they send it to the municipal treatment facility. They use peristaltic tubing pumps for their chemical feed in the back-end wastewater treatment plant, again, eliminating a myriad of ancillary equipment. And they use larger, heavier-duty peristaltic hose-type pumps for pumping the sludge that is commonly found in the back and wastewater treatment plant in a paper mill. This is a typical installation of diaphragm metering pumps, again, with all the ancillary equipment that is found in a paper mill. These pumps, the actual installation there was replaced by the simple hose pump installation that you see here. Again, my name is Rick Balick, National Sales Manager with the Watson Marlow Fluid Technology Group. Thank you for your time.